Lightning. We've all seen it. We've all seen the damage it can cause. It has been observed, studied, worshipped, feared. In the past, lightning was believed to be the angry thrashings of a higher being. Perhaps lightning is a blessing from the thunderbird, signaling the future success of the season's crops, a belief held by the Navajo Indians in Western civilization.
In lieu of early beliefs, man has always sought for a more logical reason for the existence of lightning. With experimentation and development in the technologies over the ages, we can finally begin to grasp the science behind lightning. From a weapon of the gods to a buildup and discharge of electrical energy, through what we believe to what we know now, the terrible and tremendous power of lightning has always sparked interest in the great minds of our civilizations. As Socrates once said, "That's not Zeus up there, that's a vortex of air."
In early history, there were many non-scientific explanations for the phenomenon of lightning. Myths were fabricated in order to explain what was then regarded as the unexplainable. In ancient Greek mythology, lightning was said to be the weapon of the god Zeus. Lightning was also seen as the weapon of Thor in Scandinavian mythology. These beliefs were fabricated from the awesome display of electrical energy that was unexplainable without the scientific understanding and technology available to later civilizations. One of the first scientists to try to understand the phenomenon of lightning was a rebel colonist called Benjamin Franklin. Franklin believed lightning to be a natural source of electricity. With his legendary kite experiment, he was able to confirm his thoughts on lightning's electrical properties. His experiment, which was carried out in 1752, consisted of flying a kite during a thunderstorm, which had a metal key attached to the end of the string. When sparks were emitted from the key, he knew that the electrical current had traveled from the storm down to the key. This also supported the correlation between the electrical nature of clouds and lightning's own electrical properties.
Lightning is a result of the buildup of electrical energy between positive and negative charges within a cumulonimbus cloud, or between the cloud and the ground. The updraft within a cumulonimbus cloud allows the charges to travel within the cloud, creating a positively charged top, or anvil, and a negatively charged underbelly. As the storm moves over the ground, the negatively charged bottom attracts positive charges below. These charges gather and travel up objects towards the storm. When the attraction between the charges is great enough, lightning will strike. When lightning does strike, it happens in a fraction of a second. Lightning strikes with 100 million volts and reaches temperatures of over 50,000 degrees Fahrenheit, 5 times hotter than the surface of the sun. The rapid heating and expansion of the air around the lightning creates the noise that we've come to recognize as thunder. Within a storm cloud, there are millions of teeny ice crystals that form. These particles move around, sporadically bumping and crashing into larger pellets. When these different kinds of ice particles interact, static is formed, quite similar to rubbing a balloon against someone's hair. As the ice bumps around, the electric potential of the cloud increases to the point where, zap, a bolt of lightning strikes.